Yeah, no, I went to the library. Go back to like,
I have worked in radio girl, so I always see them. I
Like,
did it.
it's I told you yesterday. I totally know what you're saying. It's still getting kind of wrong in this page. I think like, it was like kind of this part where I felt like there was a little bit going on, and I know exactly how to say it.
So, right, so it's between, so this one was between 6 and 7, right? Okay. And so you got this for 6 and that for 7, and then you would interpolate between these two. So one should be negative, the other should be positive.
Yeah.
But you're getting both are positive.
Yeah, so I did because in the notes it was like y minus x, but then also I wrote like higher cost minus lower cost.
Yes. Yeah.
So this was higher, so I changed it and I did negative 95 minus negative 65. So
Yeah.
And everything else was positive.
Yeah.
I don't know, is this part right? Because that's where I was kind of confused on. It was just the first one.
Let me take a look after the class. Yeah, we're just about 1 o'clock.
Oh, yeah.
right now, but yeah, let me look after the class and then. Yeah. Okay, it's 1 o'clock. Let's go ahead and get started. All right, good afternoon, everyone. How's everyone doing today? Good. All right, so we're going to continue on with inflation today. So I think we kind of just barely started it on Tuesday, and so we're going to keep going with that. Probably not going to finish it today, but then we'll finish up inflation stuff on Tuesday, and then next Thursday we actually have kind of an in-class workshop on entrepreneurship. So So next Thursday will kind of be a fun thing, and so it's kind of the Thursday before the midterm, because the midterm is the following week after that, and so we're about 2 weeks away from the midterm. And so, like I said, inflation. This will be the last unit that you'll see in economics. Before we kind of switch over to ethics the following week. Okay. Okay, and so that's I don't think I have anything really to announce. Homework 4 is due tonight. Make sure you are finishing up with that, and then homework 5 will be posted later today as well. So and homework 5 will kind of cover everything else that we've done. So replacement analysis. I think I have some extra tax problems on there for you just to give you some more practice with that, as well as a couple problems on inflation, just so that you can see, get some practice with that as well. Okay. So homework 5 will be posted tonight. It's not going to be due next week. It'll be due the following Tuesday. So it'll be the Tuesday before the midterm exam. Okay. All right. Okay. So are there any questions I can answer before we get started today? Okay. All right. So let's go ahead and pick up where we left off. And so I think the last thing we did before, before we left off was, we introduced this idea of inflation, where inflation is basically just going to be an increase in prices. Okay. And we talked about all these different causes for inflation. Okay. And so today what we're going to do is we're going to define some more terms regarding inflation. So this is from last time, and so you guys should have this in your notes. We're going to define some extra terms, do some calculations, and hopefully that'll make things a bit more clear. Okay. All right, so just as a quick recap, inflation, when we talk about inflation, we're not really talking about the cash that we have, but we're talking more about the prices. Okay. And so when we talk about inflation, what we're saying is that the price or the cost of goods and services is going up. Okay. And so there's this idea called purchasing power that will be kind of pushing around a lot today. Okay. And so it's one thing to have cash, it's one thing to have money. Another thing is to talk about what kind of purchasing power you actually have with that money. Okay. Because like I said last time, you could have $1 billion, but if a banana at the market costs $2 billion, then $1 billion is useless, right? And so, purchasing power is about the value of goods you can buy with cash. Okay. And generally due to inflation, if you have a fixed amount of cash, and so we'll go back to the kind of the example we talked about at the beginning of the semester. So if you have just $100 bill in your pocket, due to inflation, every year you kind of hang on to that $100 bill. The $100 is not changing, but then the prices of the goods that you're getting is going to be changing. So over time, due to inflation, the purchasing power of that $100 will go down. Okay? Okay. Right, and so like I mentioned last time, inflation's been in the news quite a bit, just because I think it's the thing on everyone's mind right now. And a lot of times, if you're working for a company, you can compare, the amount of raise or not that you get from the company versus inflation, right? And so, let's say you work for a company and they give you a 3% raise, okay? And so what that means is that the yearly salary or the monthly salary or your hourly rate, that's going to raise by 3%. Okay. And so, you might be thinking that's good, or, at least the company's going to try to sell it to you that like, we gave you a 3% raise, but if there's an 8% inflation rate, and so that means that all the things that you have to purchase, your food, your rent, your gas, everything's getting 8% more expensive, then a term that you might hear, or the way that people might say it out there, is say that if your raise is not at least the same as the rate of inflation, then you're actually taking a pay cut, right? That's kind of a misnomer. They're not actually taking money away from you. And so you're not actually losing money, but you are losing purchasing power. Okay. Okay. And so, yes, with a 3% raise, you are getting 3% more cash, each year from your salary for your job. But if everything else is 8% more expensive, then it doesn't really matter. That 3% raise kind of gets eaten up by the price of everything. And for this particular case, this is kind of what we're dealing with here at Cal State Fullerton. So that one kind of hits a bit home. Okay, so let's unless you're Fram, of course, then you get a 30% raise unless you're Fram. All right, and so let's define some additional definitions regarding inflation. So some of these we've already kind of implicitly defined, but it's good to kind of just define them explicitly. Okay, so first we have the inflation rate. So we've already kind of defined this, but the symbol that we're going to use for it throughout calculations today is F. Okay? Okay. And so the inflation rate is just basically the rate at which prices are going to increase, over the year. And so usually, these are usually computed on a month-by-month basis. And because it's such a hot topic now, you see it talked about in the news all the time now. And so when they say that inflation was 8% back in September or August or something, that's not to say that prices rose 8% from August to September. That means if you compare the prices from September of last year to September of this year, they're 8% higher. So the reporting on this can be a little bit misleading, and so you want to make sure that you kind of know kind of what they're talking about. Usually, when they define inflation rate, it's over a 1-year period. It's not over a 1-month period. Okay. Okay. All right, and then we have the market interest rate. And so the market interest rate, we've been working with, for the last few weeks. Whenever we do an economic analysis problem, I give you the interest rate. It's just now that we're going to put a different term on it. So this is the market rate. Okay. Let me do different definition. So this is the interest rate. This is the interest rate one would obtain in the general marketplace from things like loans, bank investments, or etc. Okay. Okay. And so we've talked a lot about in this class about investments. And so, when you put your money into an investment bank account and then it gives you an interest rate, that rate that they give you, that's the market rate. And so they tell you that you put your money into this bank account, it's going to grow by 1%. That's the market rate because they're going to give you 1% on your investment. Okay. So everything that we've been working with up till this point has been the market rate. Okay. It's not exactly the same thing, but whenever people talk about the raise that they get at their job, they're talking about a market rate because that's a flat amount of money increase in money that they're getting from their job. But when you factor in inflation, you can compute something called the real interest rate. Okay. And so we give this a symbol I prime. Okay. It's not that the market interest rate is fake or anything like that. They just call it real. Okay. And so what the real interest rate measures is the it's more like the interest rate on your purchasing power. Okay. Okay. And so when people talk about the real interest rate, you're talking about either an increase or a decrease in the amount of purchasing power that you would get each year. Okay. And so of course, you know, the real interest rate is going to be affected by inflation. Okay. All right. And so there's a formula that's going to relate all of these different rates. Okay, and so what we can say is that the market rate is equal to the real rate plus the inflation rate plus the product of the real interest rate multiplied by inflation. Okay. This here is the market rate. This one here is the real rate. This one here is inflation. Inflation rate, and then we have that product term. Okay. All right, so one thing that's often done, so oftentimes, you know, when you're kind of working, you know, with kind of real numbers, a lot of times you're going to be given the market rate and you're going to be given the inflation rate. And so oftentimes you're going to use this formula to compute what the real interest rate is. Okay. And so let's solve this equation for I prime. And so if we solve this equation for I prime, I'm going to go ahead and move the inflation rate to the other side. And so we have I prime is equal to I minus F divided by 1 plus F. Okay. And so that second formula there is it's the same as the first one, but I've just rearranged it to solve for the real rate. Okay. Okay. And one thing, and you'll see this, you know, in the example that we'll do, you know, very soon, that when you are using this formula here, you want to make sure that I and F are in decimals. Otherwise, you're going to get erroneous results. Okay. All right. So those are the three rates, and so we're going to be working with that quite a bit today. And so, you know, you may be wondering, you know, with these three rates here, especially the market rate versus the real interest rate, you know, when do you use one or the other? Okay. Because a lot of times it's not going to be given to you explicitly. So they're going to give you an interest rate, and then just kind of based on the context surrounding that, you're going to have to determine whether it's the market rate or the real interest rate, or even sometimes the inflation. Okay. Okay, and so let's just talk briefly about, you know, which rate that you should use, you know, in a given situation. Okay. All right. So sometimes, you know, and at least for the problems that I'll write for you, I'll tell you explicitly, you know, which rate to use, unless it's something I want you to determine. But kind of out there in the real world, it's good to know which rates refer to which one. Okay. And so generally speaking, if you're going to a bank and they're giving you an interest rate on like a savings account or like a loan. Okay. Those always come with some interest rate attached to them. So either it's an interest rate that you're going to gain from a savings account, or it's an interest rate they're going to charge you on a loan. This is almost always going to be the market rate. Okay. Whereas if you're doing some kind of economic analysis for like an engineering company, or like, or like a lot of the analyses that we've been doing in the class. Okay. Okay. And so if you're doing some kind of economic analysis, which includes costs and benefits, that's going to recur over many years. Okay. And so this will be things like, engineering projects with like maintenance costs, overhaul costs, salvage costs, revenue, all those things. If you notice, in all those problems that we've done so far, we've always assumed things like the maintenance cost is, more or less constant throughout the entire life of the project, with, not excluding some things like gradients. And so in these cases, the reason we can assume all those things is that we kind of make the assumption that we're talking about just the real rate. Okay. And so we'll be talking about like, real rate, real dollars quite a bit more, but, basically what you can assume is that when you're making kind of an economic forecast over many, many years, you're kind of basing all the costs in terms of today's dollars. Okay. And then, when you say the maintenance cost maybe like $5,000 per year, that's $5,000 of today money. But then of course that's going to change due to inflation over time. But, we'll go over that in a bit more later. But just in general, you can assume that whenever you're doing any kind of economic cost benefit analysis, basically anything that we've been doing before this week, that uses the real rate with real dollars. Okay. All right. Any questions on this so far? It's going to get confusing, especially maybe not so much now, but then once we start kind of getting a bit deeper into this, it's going to be a bit, I'm going to say it, and then even when I say it, I feel like it's a bit confusing for me to say, so I kind of have to talk. You'll see me kind of talk my way through some of these things just to make sure it still makes sense to me. But it can be a bit, confusing. So don't feel bad if you're confused after today, because there's kind of a lot to keep in mind. But let's start with the relatively simple example. Just to kind of put a lot of things in context. Right? And I think this example was kind of a good illustration of, the three different rates that we talked about so far, as well as kind of showing what can happen with inflation. Okay. And so in this example, let's say that we are managing the money for a professional golfer. Okay. And so let's say that this professional golfer recently won a tennis tournament, a golf tournament, maybe a celebrity tennis tournament. But she recently won a golfing tournament. And what do golfers do with their money? Of course, they buy more golf balls. What else would golfers do, right? And so to make sure that she can buy golf balls in the future, she's going to invest some of her winnings into a high yield bank account. Okay. And so she wants to be able to buy, the golf balls in the future, and she's going to use part of her earnings to do that. Okay. Okay, and so what she's gonna do is that she's gonna take $1,000 of her earnings and she's gonna invest that in a bank account with 5.5% interest rate. Okay. All right, another thing that we can assume is that the prices of golf balls are going to grow at 2% each year. So golf balls are going to become 2% more expensive each year. Okay. All right, so that's the context. And so we have three parts of this problem. And so in part A, we're going to identify and if needed, compute the three rates. And so we're going to identify what the market rate is in this problem. We're going to identify what the inflation rate as well as the real interest rate. Okay, so we're looking for I, F, and I prime. Okay. Okay. And so part B, we're going to assume that golf balls will cost $5 each today. Okay. And then we're going to compute how much they're going to cost in 1 year. Then we want to compute how many golf balls can they purchase today with that $1,000. But if they wait a year and their money grows in that bank account, how many golf balls will they be able to purchase in 1 year? Okay. Okay, so that's part B. And then part C, we're going to redo this entire problem, but then we're going to assume the inflation rate is actually going to be 8%. Okay. All right. And so in this problem, you know, we have the cash that we have, right? And so the cash, we're starting with $1,000. And then to kind of represent purchasing power, I'm using this proxy of golf balls. Okay. And so the golf balls, you know, we're going to assume that they're the same quality, you know, from today and the future. And so our purchasing power is going to be represented by the fact of, you know, how many golf balls can we buy with the money that we either have today or the money that we'll have in the future, assuming with, you know, all these rates and all this. All right, any questions on this? Okay. All right, so let's go ahead and do this problem. And so let's go ahead and do part A. And so part A, we need to identify what the market rate is, what the inflation rate is, and the real rate is. Okay. Okay, so let's start with the first 5.5% we see in the problem. And so what the problem tells us is that this golfer invested $1,000 of her earnings into a bank, which has a 5.5% interest rate. Okay. And so since this this rate is something given by the bank, it represents an amount or the amount that her cash is going to grow. That 5.5% is thus the market rate. Okay. Okay. And that 5.5%, because it is the market rate, that's going to tell us how much the cash is going to grow. So that $1,000 that she's going to put in, 1 year later, she's going to have 5.5% more cash than she did. All right, so the inflation rate, this is pretty straightforward. So remember, inflation rate tracks, how much more expensive things are going to be in the future. And so it gives it to, and so this problem gives it to us in the last line, which says that golf balls are going to increase in price by 2%. Okay, so the inflation rate here is 2%. And this is because this is how much more golf balls will cost. In 1 year. Okay. Okay. And so the last rate that we have here is the real rate. And so we're not given that in the problem. And so we actually have to compute this. And so let's go ahead and compute. Okay, so let's go ahead and use the formula that we had up here. So we have the real interest rate is equal to the market rate minus inflation rate divided by 1 plus the inflation rate. Okay. And so we have I prime is equal to I minus F divided by 1 plus F. Okay. Let's go ahead and plug in for this from this problem. And so remember, we have to use the decimal representations for all of these rates. And so for the market rate, we're going to plug in 0.055. For the inflation rate, it's going to be 0.02. And then we're going to have 1 plus the inflation rate, which is 0.02. Okay. All right. And so if we punch this into a calculator, what we should get actually is 0.034. Might be 0.035, something in that range. And so that tells us that the real rate here is 3.4%. Okay. And so what that tells us is that, in a year from now, we'll be able to buy 3.4%. We'll have 3.4% more purchasing power. Or the golfer, I guess, which we'll have. Okay. And so for this problem, 3.4% more purchasing power means that she'll be able to buy 3.4% more golf balls. All right, and so that's what the real rate is representing. Okay? And so we're going to do part B on this problem to kind of verify that that's true. Okay, so let's do part B. And so part B is going to ask us if part B is saying that if golf balls cost $5, let's compute how many golf balls she can get today versus how much you can get in the future. Okay, so let's do today first. Okay, and so she were to buy golf balls today. She has $1,000 in cash. Okay, Since it's today, it hasn't had time to grow, and so we just have a flat $1,000. Okay. And then to compute how many golf balls we can buy, we're going to divide this by the cost of the golf balls per golf ball. Okay. And so if the price of golf balls is $5, then if we do $1,000 divided by $5, what we get is 200 golf balls. Okay. Okay. Now let's do the calculations 1 year from now. And so in 1 year, a couple things are going to happen. So on the one hand, her $1,000 is going to grow. Okay. Okay. Because remember, she's going to invest that $1,000 into the bank. And so while that $1,000 is sitting there in the bank, it's going to grow by 5.5%. Okay. Because that's the market rate. And so if we take, if we increase this by 5.5%, then what we get is $1,055. Okay. Meanwhile, over that year, inflation is going to take place, and so that golf ball price is also going to go up over that year. But the golf ball price is only going to go up by 2%. And so if we take 2% of $5, that's 10 cents. Okay. Then if the price of golf balls is going to grow by 2%, then the new price for golf balls is $5.10. Okay, so those are the numbers we're working with for that for that year. Okay. Now let's compute how many golf balls she can buy. And so if she has $1,055 in her bank account and golf balls cost $5.10. Okay. We perform this arithmetic and then we punch it to the calculator. What we get is 207 golf balls. Right, and so if we compare the golf balls that she can buy in 1 year, it's more than what she could buy the previous year. Okay, so she can buy 7 more golf balls. But let's go ahead and put that into a percentage. Okay, and so if we compare the 1 year from now to today, she got seven more golf balls. Okay. And so if we divide that number by the original number of golf balls, which was 200, okay, we do 7 divided by 200, then what we get is 0.035. Or in other words, what we can say is that the amount of golf balls that she could buy has grown by 3.5%. Okay. All right, so where does that look familiar? It's not quite the same, just because we're working with whole numbers here. But if you compare that 3.5% to the real interest rate that we had before, they're basically the same. Okay. And so hopefully, this kind of shows you, what the real interest rate represents. And so, it goes beyond just the flat amount of cash that you have, which is given by the market rate. But if you factor in the goods that you want to buy from that, then you can get a number of how much your purchasing power is actually increasing. And so in this case, it's increasing by about 3.4, 3.5%. Okay. So the general rule of thumb is that if your market rate is greater than the inflation rate, then of course your buying power is going to increase. Then your real interest rate is going to be greater than 0. Okay, so in this case it's 3.5%. But what you'll see is that in part C, if the inflation rate is greater than your market rate, you're going to get a negative real rate. So that means your buying power is going to decrease. Okay? But that's kind of the rule of thumb that you can use. All right, any questions on this? All right, so let's do the same problem again, but then let's use inflation rate of 8%. Okay. And so in this case, the inflation rate is going to be greater than the market rate. Okay. And so like I just mentioned, this tells us that our real interest rate is probably going to be negative in this case. Okay. All right, so let's go ahead and compute that. So we have I prime, this is equal to I minus F divided by 1 plus F. Okay. And so our market rate in this case is still 0.055. Our inflation rate here is 0.08. And on the denominator, we have 1 plus the inflation rate, so 1 plus 0.08. And so we punch in all the numbers for that, then we get a negative 0.023. So this means our real interest rate is negative 2.3%. All right. So I'm not going to go through the entire golf ball calculation again, but I'm going to use this interpretation here. Okay. And so if our real interest rate is minus 2.3%, this means that we're going to be able to buy, or the golfer is only going to be able to buy 2.3% less golf balls in 1 year. Okay. And so in 1 year, and so if we take our 200 golf balls, and then we multiply it by 1 minus I prime, this is going to tell us how many golf balls that we can buy in a year. Okay. And so we take 200, we multiply by 1 minus the real rate, and so this is going to be 0.977. Okay, because that's 1 minus 0.023. And we multiply this out. Get 195 golf balls. Okay. All right. And so, in this case, when the inflation rate is greater than your market rate, or in the case of your salary, if the inflation rate is greater than the amount of raise that you get from your job, then you're going to get less purchasing power, in the coming year. Okay. All right, any questions on this? Okay, so hopefully, that example was helpful just to illustrate, all these concepts. Let's introduce some more concepts. Okay. All right, so let's talk about the types of money that you can have, when you're talking about inflation. Okay. Or I guess different concepts of. Okay. And this is where things get confusing because I will be the first one to tell you that I hate the naming convention that they use for this because they both sound like the same thing. They're just kind of the descriptors are kind of synonyms for each other, but that's the name that they went for it, and so we got to teach it like this. Okay. And so the first type of money that we have are called actual dollars. So sometimes you see me use the symbol A with a dollar sign. Okay. So actual dollars are kind of real. I can't use real. The actual dollars are like the tangible money that you have in your pocket that's actually exchanged for goods and services, or that you actually invest in them. Okay. So this is like physically tangible money. So this is the money that you actually use to buy stuff, invest in stuff, the actual money that you get from revenues, selling stuff like that. Okay. All right. So sometimes these are called inflated dollars because if you have actual money, then because of inflation is going to make this actual money lose value over time. Okay. And so an example that kind of illustrates this, we kind of talked about it earlier today, is actual physical money, right? And so if you have, let's say you have a $10 bill in your wallet and you keep it in your wallet for 10 years, or you keep it in your pocket for 10 years, okay? So that $10 bill today can get you, a pretty decent lunch, right? You can go to like Panda Express, you go to Subway, you get a meal, you get a drink. That $10 bill is probably going to cover that cost. Okay? But in 10 years from now, let's we'll see that again. And so and what's interesting is that I first taught this class maybe about 3 years ago, and I thought $10 back then was really good. You get a really good lunch for that. But even now, things, I mean, the last few years have been kind of crazy, but but now, $10, maybe you're getting up to that $10 limit in terms of what you can get. All right, so that's actual dollars. The second concept of money that we'll go over is what's called real dollars. Okay. And of course, this corresponds to the real interest rate that we've been talking about. But when you compare it to actual dollars, real and actual are literal synonyms of each other. So you look one up in the source, you'll see the other one, and then the exact same thing. So I think this is where a lot of people get confused. Okay. And so when you talk about real dollars, this is not physical money that you were talking about. Real dollars kind of are more of a concept of purchasing power. And what's important for real dollars that's different from actual dollars is that you have to give a time basis, or you have to define when, what time period that real dollars represents. Okay. And so the way that we define this is through what's called the time base. Okay. And so when you talk about real dollars, you have to kind of say what time period or what year that those real dollars are meant to represent. Okay. Because if you talk about $10 of purchasing power in 2022, that's going to be real different than $10 of purchasing power back in 1972. Okay. All right. So as opposed to the actual dollars, real dollars kind of it factors in inflation already. So sometimes people will call these inflation-free dollars. Okay. And whenever you're talking about real dollars, they have to have a base. Okay, and so those are the two types of money. And so what we'll talk about next is how we can relate these two. And the way that we can relate them has a lot to do with the rates that we've gone over. And so we'll see how the market rate, the real interest rate, and the inflation rate kind of factors into all of these. Okay. But before I get there, are there any questions on this? Okay. All right. Okay. So let's talk about how these different types of money are related. Okay. And so there's four rules associated with this. And so what the four rules are going to define is, if you're converting between certain types of money and different time periods, you're going to use a different rate. Okay. All right, so I'm going to list out the four rules. All right, so rule one is when you're converting between actual dollars in one time period to actual dollars in another time period, then you're basically from actual to actual, then you're going to use the market rate. Okay. So that's what we did in the previous example. Yeah, question.
So instead of real dollars, what does it mean by the dollar?
Say again?
What does it mean by dollar?
You mean purchasing power?
Yeah.
So it's basically a rough estimation of the value of goods in that time period. And so if you say that, you know, let's say today, right? So you buy $10, that's worth about a fast food, right? So you go to like, you know, In-N-Out, El Pollo Loco, you get $10, you get a meal from that. But if you talk about $10 of purchasing power, say 40 years ago, you know, you could probably buy 3 fast food meals, 2 or 3 fast food meals. So and so when you're talking about real dollars, you have to say, you know, what time period that you're in, and then that gives you some context of the rough price of the goods in that time period. Yeah. Oh yeah. So when converting actual to actual, you want to use the market rate. So we saw this in the golf example. And so, you know, when we talked about the $1,000 that the golfer was investing, that $1,000 was actual money. Like she won that in the tournament, and she can actually use that to buy golf balls. And so that's actual money. And then when she invested that in the bank, we used the market rate. Right? And so through the market rate, once she kind of withdrew that money a year later, she had 5.5% more actual money. Okay, so actual, you're going to use the market rate. Okay. All right, and so number 2 is when we're converting real dollars. And these real dollars have a certain time base. And we're going to convert that to real dollars in another time period. But that real dollars in the other time period has the same base as before. So this is where things get a little bit confusing. So, you know, the time base is going to stay the same between the 2 real dollars. And so, you know, let's say we're talking about real $10 of purchasing power in 1972, and then we want to see, you know, how much that's going to grow to 2022, but we still keep the same time basis of 1972. Then in this case, we use the real interest rate. Okay. So 2, I think, could be a little bit confusing to people, but generally speaking, when you're going from real to real, so real dollars in one time period to real dollars in another period, then you're going to use the real interest rate. Okay, so real stays with real, the market stays with actual. Okay. Okay. And so rule number 3 is the first time we're going to kind of cross between them. So when you're converting actual dollars in one time period to real dollars in the same time period with the same time base. Okay. Right, and so we're comparing real and actual dollars basically in this exact same moment in time. Okay. And so in this case, you actually use no conversion because these 2 represent the same thing.
Okay. Right, because if you have actual money in your wallet today, then that's real purchasing power that you have today as well. Okay, so the $10 you have in your pocket, that's actual money, but then you can also think about it as $10 worth of purchasing power today. All right, and then finally, rule 4, which I think is the most confusing one. And so when you're converting between actual, when you're converting real dollars of some time base t, okay? And so the real dollars may be based at some other point in time, okay? And so, we may be talking about real dollars and, of a time base of back in 1972, okay? Okay. Okay, and so if we're converting real dollars, and so in this case, the time base and the actual time that we're measuring stuff may not be the same. Okay, and so I'm going to call the time base t and the actual time that we're measuring n. Okay, and then we're converting that to actual dollars at the same time n. Then in this case, we use the inflation rate. Okay, and the inflation rate is going to be applied for n minus t time periods. Okay. So I think rule 4 is the one I think that trips people up. But the way to kind of remember rule 4 is that when you're basically comparing actual amounts of money to a different time. And so question 4 is basically, or point 4 is basically asking the question of, if I have $10 today, how much purchasing power would that be in another time period, right? And so in that case, you're applying the inflation rate, because the inflation rate will tell you, how much purchasing power has changed in one period to another, right? So as an example, let's say you have $100 today, right? And you're curious about, how much purchasing power would that happen, or would that be, would that have back in 1972? Okay, so how much stuff can I buy for $100, 50 years ago? In order to compute that, what you're going to do is you're going to need to strip away that 50 years worth of inflation. And so in between, 1972 and 2022, we've undergone inflation for 50 years. So we're going to use the inflation rate. You're going to strip all that away, and so you're going to, remove inflation for those 50 years, and then that's what's going to tell you, how much actual purchasing power that $100 would have back then. Okay. All right, and so there's a chart to kind of help you, remember these rules. Okay, so let me go ahead and draw the chart. Okay. Right, so on the top of this chart, I'm going to have real dollars. On the bottom, I'm going to have actual dollars. Okay, and so if you have real dollars base t at some time t, and you compare that to actual dollars at the same time t, okay. In this case, you don't do any conversion, because these two are the same thing. Because actual dollars at some time t is the exact same thing as the purchasing power at that same time t. Okay, so this is basically rule 3 right here. Okay. Okay. And so if you look at that real dollars and you keep the same time base, and so you keep the same, purchasing power base back in, the past, and you're converting, but you're up converting that to the current time, at time n. Okay. In order to make this conversion here, you're going to use the real interest rate. So this is going to be I prime real. Okay. And so that's rule 2, remember. Okay, so remember, real to real, use the real interest rate. Okay. Then on the bottom, we're converting actual dollars. So actual dollars at some time t, and actual dollars at some different time n, which may be in the future, maybe in the past. Okay. Okay. And so in those cases, you're going to use rule 1. Okay, so remember, doing actual to actual, and you're going to use the market rate. Okay, and then finally we have rule 4. And so rule 4 is if you're converting basically a real dollars at with some different time base t with actual dollars, at the same time, then you're going to use inflation. Okay, because that inflation is going to affect how much purchasing power that actual money may have. Okay. So I know this part is confused. I think this is probably the most confusing part of this unit, but I do have another example here to kind of illustrate this to hopefully make it a bit more clear. Okay. And we have about 10 more minutes, and so I think we'll be able to squeeze it in today, and then we can finish our discussion of inflation on Tuesday. Okay. All right, any questions on this so far? All right, so let's do one more example, and then we'll wrap it up for today. Okay, so in this example, let's say that a certain sports stadium was completed in 1965 for a cost of $1.2 million. Okay. Right, so that's 57 years ago. And so after that stadium was completed, the owner of the team at the time knew that he was going to have to renovate, or in the worst case, tear it down and build a new stadium. And so he wanted to invest some money today in order to pay for that stadium in the future. Okay. All right. And so looking at his at the first stadium, he saw that it cost $1.2 million. The owner said, "Why don't I take the same amount of money? I'll take $1.2 million and invest it over that time to pay for the eventual stadium replacement." And then let's say that the market rate for that investment was 8%. Okay. And so his logic at the time was that, you know, I paid $1.2 million for this first stadium. And so if I take another $1.2 million, invest it at the market rate, as long as that market rate stays above inflation, then, you know, when I need to buy a replacement, and let's say it's 2020, okay, when he wants to buy a replacement in 2020, then the new replacement will be just as good as the old one because the market rate is going to stay above inflation. Okay. Okay. And so let's say over that time period, inflation is going to be 6%. Let's do the following. Okay. So this problem has already given us the market rate and it's given us the inflation rate. And so we can use this to compute the real interest rate. And what we'll do too is that we're going to characterize that $1.2 million investment in terms of actual dollars and real dollars. And so we're basically going to describe what that $1.2 million investment is going to be like. Okay. Okay. Part B of this problem, we're going to compute the actual dollars that comes out of the investment if it was pulled in 2020. And part C, what we're going to do is we're going to compute the real dollars worth of investment, real dollars worth of the investment in 2020 in terms of 1965 purchasing power. Okay. Okay. All right, so this example here is going to be a good one for all the different rules, and so we're going to make use of all of them to, or almost all of them to do the different parts of this problem. Okay. All right, any questions on the setup of the problem? Okay. All right, so let's go and get started. All right, so first let's compute the real rate, and so we've done this before, and so the real rate, I prime. We're going to take the market rate, we're going to subtract the inflation rate, and then divide it by 1 plus the inflation rate. Okay. So we're just going to plug into this formula. And so if we do that, we get 0.01887. And so if we convert this to a percent, this is 1.887%. Okay, and so the second part of part A, that's asked us to characterize that $1.2 million investment. Okay. And so what this means is just to describe kind of what that $1.2 million represents. Okay. And so since this is money that the owner had back in 1965, that's actual money that he had. Okay? It was physically tangible. Maybe he couldn't touch it because it was in the bank, but you could actually use it to invest in stuff. We can also characterize in terms of real dollars. Okay, and so if he didn't invest that 1.2 million into his new stadium, then he could buy $1.2 million worth of stuff in 1965. And so another way we can describe that 1.2 million is it had real purchasing power in 1965. Okay, and so it you can buy $1.2 million worth of stuff back then. Okay. Okay, part B. And so part B asks us to compute the actual worth of the investment withdrawn in 2020. And so this owner put in $1.2 million in 1965. He's going to let it sit there for 55 years and then pull it out in 2020. And we just want to know just the raw, physical, actual amount of cash that he's going to withdraw. Okay. And so in this part of the problem, we're going to do an actual to actual conversion. Okay. And so if we go back off the rules, this tells us we're going to use rule 2, and we're going to use the market rate. Okay. And so to compute F, here we have 1.2 million. Okay. And so if we consider the present day or the past to be 1965, then we're going to do an F over P conversion. Okay. The market rate for this problem was 8%. And then we're going to push this forward 55 years. Okay. So we're going to do an F over P, 8%, 55. Okay. And so once we plug in the numbers for all that, we get $82,701,600. Okay. Okay. So that's the actual amount of money that he's going to pull out. Okay. So it's a lot, but 55 years is also a very long time, and so it makes sense that it's going to grow by that much. But whether or not, that may seem like a lot, right? And so 1965, the stadium only cost 1.2 million, but a lot can change in 55 years as well. So we have 6% inflation. And so even though his money is growing by 8% each year, the prices for all the materials, the labor and everything is also growing by 6% every year as well. And so, that's going to affect the kind of stadium that you can buy in 2020. Okay. All right, but we are just about out of time, and so I hate to kind of cut it off right before before we finish an example, but I also don't want to leave you guys here for any longer. And so, are there any questions on just this parts of the example here? Okay, all right. So we'll come back on Tuesday. We'll finish up this example, and then we have just a few more pages of the inflation notes, and then we'll be done with economics. And so, thank you guys all for coming today. Thank you guys for joining on Zoom, of course, too. And so hope you guys all have a great weekend, and I will see you guys on Tuesday. Yep. Yep. Yeah. Oh, by the way, so on the homework, the very last tax problem, it's kind of like a challenge problem. And so that one, I basically just threw the whole kitchen sink at you. And so try your best with the last part. If you get it, that's great. If you don't get it, just give me your best effort, and then that's all I'm gonna ask for that.
So I tried.
Okay. Yeah.
Using the model differential and then.
Yeah.
The things for the tax law, that's percent.
Yeah.
And then after that, I think that's revenue minus expenses, inflation.
Yep.
So I got the state tax law involved, and then tax percent of that.
Yep.
And then I think there's a problem, it says like adding up together, state tax and state tax income.
Yeah.
Related to the federal function.
Yeah.
At that point, I also multiply it point two.
Yeah.
Come with that, and then this one, I add them up with, I think, what else, revenues, and then the federal tax and the state tax.
Yeah.
Come up with that, so book value, I like all of them have a zero.
Okay.
However, present work, using the after tax cash flow.
Yeah.
I got a 7,000.
Okay.
7,800. I don't know where that is.
I would need to look at my numbers just to kind of verify, because there's a lot going on with it.
Yeah.
And so if you want to email me your work for this, then I'll take a look, and then I'll see if there's anything that.
Okay.
I redid this one too, and so I might have made some mistakes with there's just so much fun. So, and so I did this in Excel, so I would need to check all my formulas in there and make sure that's all. Okay. Yeah, send me your work and then I'll check it with you.
Okay, I will. This one, and then I'll submit the exit files.
Okay, yeah, sounds good.
Thank you.
Yeah.
But it also. Formation. Yeah. I'll see you later. Okay.
All
All right, yeah.
Let me pull up the homework problem too, just so I can double check. Actually, Zoom people, any final questions before I wrap it up?
Hey, do you go to library? Yeah. Just put down.
Bye.
Questions?